Welcome to a new test and teardown video. This time it's a Nixie timer counter from Advanced Electronics. It's called TC6. And yes, we got 6 Nixie tubes in here. I definitely need to perform a little bit service. So it's definitely open first and then do a little service before we can even power it up for the first time. There is a little thing about this one that is confusing me a little bit. It is the same Advanced logo, but now they're called electronics and not instruments. So that's a little bit interesting. I could not Google this in any possible way. So if you happen to know how to find any kind of information about this timer counter TC6, I would really like you to contact me and send me some information. I kind of like all these features about periods and frequencies, and we got some check. We got count this and count that. We can start and we can stop manual. We can of course hold the display, and in either count or frequency mode, I guess this is all the different timings in gate time or the pulse times for the time interval, or between start and stop pulses. I guess if you put these down to contact, it's probably this start stop here, or maybe they're supplying a voltage to that signal here, so you can put a contact between start and stop, so you don't need any external voltage. So that's pretty cool. AC or DC, and then trigger level, plus minus. And this is probably a test point where you can put a voltmeter, and then you can measure that it's going on and off. And then you dial this, and then here you got the trigger. That's pretty cool. Oh, this one needs a little service. Oh, as you can see, this one is really, really old. The handle is just completely dissolved. And this is, I think, raindrops. So somebody threw this out and in the rain. Really? Who would do such a terrible thing? What have we got here on the back? Yes, Advanced Electronics and all that kind of stuff. And it is set for 200 to 250. We got a little bit of, what is that exactly? Yeah. I'll just open this one and have a look. That is one funny surprise. Look at that. So the case is one solid piece that goes all the way around. And of course you need to loosen all those screws. And also a few here. And then slide the entire cover out the back like this. I mean, that is a fun surprise. I think this one is just so fantastic. I love it already. Look at the build quality. Oh, it's just amazing. It's of course very, very dirty. And this one is really, really old. So somebody didn't have the original fuses. So they made a little modification like that. How about that? Overspill. How about that? Yeah. I will definitely see if I can find some date codes on anything. How old is this one? So here's a rectifier modification or something like that. Is that original? Because this is a more modern type of rectifier. And down here, that will be a time correct selenium rectifier. We got all sorts of capacitors, stuff going down. Look at those timer boards. That is just a million gazillion transistors. So how do you pull out one of those modules? Because as you can see here, they are, well, they're connected to the back plane, right? But you can't pull that because you're gonna hit that one. But yeah, I don't know. And we got some other modules here, time base and count, start, stop, dividing this and that. And there's some sort of a black isolation tape around this one. So that is something I have to open and have a little look here. It's also really, really dirty. So I will go and get my compressed air and see if I can clean this up, and then hopefully fix this screen plastic here. See if I can get this up. So after a little bit of cleanup, now I can see components, and there's actually another fuse here on the inside. So we got 3 fuses. That's a little bit unusual. I now know why we had some plastic around this board. It's for several reasons, because you can see the distance to this piece of metal in there, and the distance to that other board here is not so good. And it's because I removed this piece of plastic here. So it's a piece of plastic on the back side, and it's been cracked. And that one is the one that was supposed to hold this circuit board like that, that one like that. Okay. So I'm going to see if I can figure out how to pull these boards out. Well, there's definitely a way to do that. Ooh, this whole thing here can... I don't know exactly what I'm doing here, but I think I will put the plastic bag on again and then try and power it up, and let's see if there's any kaboom in this one. So let's try and dim the light a little bit here. Look at that, it is alive. Why is that one so much brighter? It's also bigger. Oh, it's completely different. So somebody replaced one of the Nixies with another type. What the heck is that? See, that one was better. Wow, it's a lot bigger. That is dumb. Okay. So what can we do with this thing? Count, time, yada yada, frequency. Oh, we got some. What about check? No. Frequency, and then it's probably, yeah. So we got some dots moving around like that. So here is one. How about we just input something here, right? Let's see if there's any kind of, what am I doing? Hello? Hello? What is that? So let me give you 1 kilohertz. Is that what you want? It's just counting. Aha, so I don't know. I've been playing with this for quite a while now, and I thought I had the idea that I could take the output pulse per second and put it into the reset, and then I could probably count. See, that is definitely my input. See, it is responding. See, that's my input. It's counting my input, and see, it's not responding to anything like that because it's just in counting mode. See, it's also resetting. I cannot get it to. See, now it's manually counting every pulse I do here. It's probably not even affected by. Yes, exactly. So yeah, there's a lot of stuff that is working. I just don't know exactly what to do. And then, see, oops, now it's not working anymore. Hello, where are you? Why don't you want to? Yeah. It's just full of loose connections and something that is working and not working and all that kind of stuff. Oh, that is hopeless. I don't have any schematics or anything at all to go from. And there's definitely some signals missing or something like that. But anyway, I want to go and pull out some of the modules and have a look. There's probably something obvious around this. What I think that one is? I think that is a heated crystal oscillator. It looks a lot like we got, see, a crystal socket and a heater in here somehow. And it's also a trimmer capacitor around here, so that is definitely a heated oscillator where you can set 12 volt or 6 volts depending on what you do here, right? So that's probably a contact when it's warm or cold, right? So that's definitely the crystal oscillator down here. And that will be the first counter module with all the transistors. Maybe it's running some sort of a BCD counting systems, and then we'll have some diodes, and then it's decoded into those 10 transistors driving the Nixie. I don't think it's counting directly in this 10 kind of system. I think the idea is that I unscrew these and try and remove this bracket, and that will allow me to pull out the boards. I think that is the idea. Talking about the hard level, I mean, those nuts, they go here under the bottom of that bracket, and there's, as you can see here, it's really, really difficult to get in with tweezers and hold those nuts. And one thing is to get stuff out, and one thing is to get this back again. And here's a little trick for you. If you're ever going to do something like this, how about you just put a thread in this piece of metal so it's easy, okay? Let's do it easy. Yes, I was right. Look at that. So there's a nice little hinge, and the whole thing can just tilt up like that. Easy peasy. The only problem was that annoying bracket here. That's just mission impossible. Oh man, I'm gonna go and yell and scream when I need to put those damn nuts back there. But anyway, I think we're finally getting closer. I want to take out one of these modules and let's have a little look. So here's the board with the larger Nixie, also called Numicator XN13. And I think I know now how this works. You can see all those diodes down there. So that will be a binary counter and some reset stuff, and then some decoding logic, and then it goes to the 10 readout transistors. That is of course how it works. The thing is that I get some really nasty stuff here on my fingers from touching those boards, and that is because they are really nasty, corroded. You can see all that. It's like it was left outside on a rainy day for many, many years. You can even see all sorts of really shorting, corroding bad things here. So this one is so much up for a deep clean and a new layer of varnish and all that kind of stuff. So that is a huge work to do. So that was the larger Nixie. Let's have a look at the other ones. What are they called? And that will be the next module in the line with a Nixie the right size. And what do you know? This one is also called exactly the same. And they're from 65. So this unit is probably from 65. I'm trying to see if I can find any kinds of date codes on some of the transistors. That will be high voltage transistors. These are just called C407. Yeah. And this board is of course also extremely badly corroded. Oh no. That is going to be 10 long days of work. So that will be the next board. This is one of the logic boards down here. It's also called logic, and it's definitely super old transistors, early transistors from 1960 something. I don't even know these S404. It's gonna be funny to try and look some of these up. COSEM. And what about these GET889? Some interesting stuff going on here with diodes and transistors. You can create all sorts of gates with transistors and diodes. I really want to show you something funny. Look at this capacitor here. It was designed to go in that hole, but they had to cut that track and move that because that metal thing down there would touch the hot part of that almost. So to create enough isolation distance, this is how you do it. Isn't that funny? And it's the same problem up here. You see this resistor here? It was supposed to go to the right, but that is of course where that top metal part goes up. Oh man, if they only had a little 3D assembly of everything like we have today. Just saying. There's also another little fun thing about this board. So this one is tinned, and the fun thing is it's really nice and clean. So that is a little bit funny to see that. Also, I want to show you the distance between those two transistors. I don't know if you can see the distance here, but I would say they are as close as touching if they are not touching. And that will be the metal case, right? So, oops, that's dangerous, huh? They are not connected together, right? That is bad. That is not a good design. You can probably find many more of those little dummies in here. So the last two modules, they're exactly the same. But here you're going to have a little bit of fun. This one is called triple decade. So that means 10 times 10 times 10. Time-based division and all that kind of stuff, probably what this is. And again, they're making this this counter with not 4 bits but 5. But I think the last one is the reset system for the 4 bits, and then some diodes to do a special reset of the binary system. So that will be 1, 2, and 3. Really fascinating. So I've been cleaning the boards a little bit, and assembled everything. I also cleaned all the nice Nixies, and now the plastic front here is glued into place. There was a nice little piece here, that one, so I glued that as well. I always use transparent contact glue for stuff like that, because if you get a little bit on the screen or something like that, then it's not going to be visible. So I hope it's a little bit better, but I really don't expect it to be fully operational with all the different features. As long as it can count a little bit, start, stop, and stuff like that, I think I'm just about happy about it the way it is. So let's try and assemble everything. It is not working a lot better after all this cleaning and contacts and stuff like that. It may be a little bit more stable, I must probably say that. Nixies look a lot better now the glass is mounted, and I think I will leave the instrument in this state for now. But I wanted to tell you thank you very much for watching, and please come back again soon. See you. Bye bye.